Hello, my name is Ahmet Monis Nawaf, Cukurova University Computer Engineering Department. Today I'm gonna talk about communes and KNN algorithms and perform a simple test codes on Python to compare results. The two most commonly used algorithms in machine learning are communes clustering and nearest neighbors algorithms. Often, those two are confused with each other to the presence of a call letter, but in reality, those algorithms are slightly different from each other. Thus, Kami's clustering represents an unsupervised algorithm mainly used for clustering, while KNN is a supervised learning algorithm used for classification. Talking about K-nearest neighbors, or KNN, being a supervised classification algorithm, K-nearest neighbors needs labeled data to train on. With the given data, KNN can classify new unlabeled data with analysis of the K-number of the nearest data points. Thus, the variable K is considered to be a parameter that will be established by the machine learning engineer. Thus, K-means needs training data to make predictions. Now, I'm gonna run sample codes on Python for each K-means and KNN algorithms. First of all, let me show you my database, my dataset, sorry. My dataset is as follows. Of course, I'm gonna ignore this column, the class column, for K-means. In this code, in this script, I'm importing important libraries. Here I'm using sklearn to import k-means library. Here in this line, I'm importing my dataset. Now in this code, I'm gonna use the elbow method. The elbow method is a good method to estimate the k number, the clustering number. So let's run this code and see how much k should be in this dataset. As we can see in this elbow line, the best value can be 3. So let's go on with the 3 value for the K value. As we can see, I chose the number of clusters at 3 by means of the elbow method. Now, this script has no job here, so I'm gonna delete it. Here I'm performing this method as I import to calculate the clusters and plot them. So let's run this code. In this code, as you can see, I forgot to mention, we ignored the class column in this code, but we have gave label to show the 3 centroids in yellow, and we labeled this the first cluster in red, the second in green, the third in blue. Now I need to mention an important thing that K-means is a clustering technique. It's not a classification technique. So we don't have a grounded truth here to compare with. Hence, accuracy doesn't make any sense in this algorithm. In K-means, we don't have any grounded truth to calculate any accuracy. Let's go forward to KNN algorithm. As with K-means, we imported the important libraries. We imported our data set, the same of our K-means dataset. We are executing on the same dataset. We gave some labels, as I mentioned before, because this is a supervised algorithm, we need to label our dataset. We have make the split between train and test using this library. We have scaled our data because, of course, as you know, the gradient descent algorithm, which is used in neural network training and other machine learning algorithms, also converges faster with normalized features. So we have to use this normalization. Now we have made our train section, test section. Now we came to the prediction section. This is our real testing section. We are testing this method. Now we can calculate the accuracy using these lines. We are trying to classify the 30 records in this dataset. Let's see how much accuracy would give us. As you can see, this result shows that our KNN algorithm was able to classify all 30 records we made the test with. So we can say that it has 100% accuracy, which is excellent. But although this algorithm performed a very well testing with this data, we can't accept or expect the same results with all applications. It can show some difference. Now, let's comparing error rate with the k values in this algorithm. As you see, these lines are responsible to calculate the k value, calculate the error rate with the k value. Let's run this line. As I mentioned, this script executes a loop from 1 to 40. In each iteration, it means the mean error for predicted values of test set is calculated. So, according to this graph, we can see that the mean error is 0 when the k value is between 3 to maybe 7. Thank you for listening, and I want to mention that the codes for these two algorithms is in the description section.